Previously, you learned that useState is a hook that allows you to persist a value across renders and trigger a re-render when the value changes. You also learned how to use it, specifically that useState returns an array with two values, the first being the current value of the state, and the second being a function that can be used to update the state. Though creating a simple counter app gives us a gentle introduction to useState, it's not super practical. Let's look at some other use cases that'll give us more insight into how we can leverage useState in more scenarios. We'll have an app that walks through the following state progression. We'll start with a single piece of state. We'll add multiple pieces of state to the component. We'll update our state to see how we can manage that state when it's an object. And then we'll update our state to see how we can manage state when it's an array of objects. Naturally, though it seems stereotypical, the best app to build to see this progression in isolation is a to-do app. Don't let the simple nature of this app fool you. After this lesson, you'll have a first principles understanding for managing state in React, and you'll be able to apply it to any app you build, regardless of the complexity. In fact, if you felt that this course has been too simple so far, this is the lesson where it starts to ramp up. First, let's start with the UI for a single to-do item. Eventually, we'll create these dynamically whenever a user adds a new to-do item to their list, but for now, we'll hard code it. Next, we need to make our app interactive. Specifically, we want to give the user the ability to toggle the status of the to-do item. To do that, we'll add some state to the component to keep track of the status of the to-do item, add an event handler to update that state, and then hook the event handler up to our input via its onChange prop. At this point, whenever the user clicks on the checkbox, completed will be set to the opposite of whatever it was, and the component will re-render with the new value. Cool, and mostly worthless so far. Let's add some more functionality. Specifically, let's add the ability for the user to edit our single to-do item. First, to make our to-do item editable, we need to move it out of our JSX and into a state variable so it will persist across renders. Next, we'll need some state to keep track of whether the user is currently editing the to-do item or not. And then we'll add a method that toggles that new editing state and hook that method up to a button the user can click. Now, because we have our editing state, we can dynamically show or hide our input field based on that state. So at this point, whenever the user clicks on our edit button, the to-do item will be replaced with an input element. Now we need to make sure that whenever the user updates the input field, we also update the label on our state. To do that, we'll create a new handle update label method and pass that as an onChange prop to our input field. Now, whenever the user edits the value in the input field, we'll update our label state. So at this point, our app is progressing nicely, but you may notice something a little strange. Currently, we have multiple pieces of state representing one to-do item. That works, but it won't scale well when we add more to-do items. How can we fix this? What if we represented our to-do item as an object instead of individual state values? Now, we need to make two changes to our code to match our new state structure. First, we'll update our JSX to reference label and completed as properties on our to-do state rather than as individual variables. And then we'll update our event handlers to handle our to-do state as an object rather than as individual pieces of state. This brings up something interesting. Notice that we're passing setToDo a new object, but we're copying all the properties from the current to-do onto it using the object spread syntax. It's important to note that when you pass a value to useState's updater function, whatever the value you pass will always replace the current piece of state. What this means is that if you have a piece of state that is an object, it won't be merged with the current state. Instead of replacing the object, you most likely want to merge the new value with the existing state object. To do that, as you saw, we can use JavaScript's spread operator to spread all of the existing key value pairs onto a new object, then pass that new object to the updater function. So at this point, our app is coming along, but unfortunately, it still doesn't resemble much of a to-do list. This highlights a problem with how we've currently architected our app. Right now, the state of each to-do item is coupled to our to-do component. On the surface, this seems like a good idea. We're keeping the state of each to-do item close to the component that renders it. The problem is it's a little too rigid. With this architecture, how would you go about adding another to-do item? Your intuition might be to just render another to-do element. But now we have multiple to-do items with the same label and ID. And not only that, what happens when we want the user to be able to create their own to-do items? How do we make it so our to-do composer element can dynamically create new to-do elements? What if instead of having each to-do component manage its own state, we lift that state up to a parent to-do list component? This would solve all of our problems. To-do list would own and manage the state of each to-do item and then we can pass the data down to the components that need it via props. In fact, learning when and how to lift state up is one of the most important aspects of state management in React. Here's the rule of thumb. Whenever you have state that multiple components depend on, you'll want to lift that state up to the nearest parent component and then pass it down via props. Oftentimes when lifting state up, you decouple where the state lives from the event handler that updates that state. To solve this, you'll create an updater function in the parent component where the state lives and, via props, invoke that function from the child component where the event handlers live. All right, so back to our code now. Let's lift our to-do state up to a new to-do list component as shown here, and then pass it down via a prop to the to-do component. And now, before we update our to-do component, we need a way from inside of that to-do component to update the state that's now located in the parent to-do list component. Whenever you're in a situation like this, what you'll want to do is create a function in the component where the state is located, and then pass that function down via props. Then you can pass data back up to the parent component by passing an argument to the function that was passed down. So now back inside of our to-do component, we need to move some things around. First, we'll remove the local to-do state and accept it as a prop since it now lives inside of the parent to-do list component. Now, since we'll be rendering multiple to-do elements, we'll update the HTML4 and the inputs ID to be unique based on the to-dos ID. Next, we'll update our event handlers to use our new handle update to-do prop that we also passed down from the parent to-do list component. The biggest thing to notice is the relationship between handle update to do in the parent component and handle checkbox click and handle edit to do in the child component. I'll reiterate because it's perhaps the most important aspect of this lesson. Whenever the state you're updating lives in a different location from the event handlers that update that state, you'll create an updater function in the component where the state lives, and you'll invoke that function from the component where the event handlers live. In our case, the state of our app lives inside of our parent to-do list component. Therefore, anytime we want to update that state, we need to do so where it lives, in to-do list. Now notice that handle update to do has an updated to do parameter. This is how we get data from where the event handler lives in a child component back up to where the state lives in the parent component. It doesn't matter where handle update to do is called, it just matters that when it's called, it receives this updated to do argument. So at this point, our app is in better shape than it was before, but it's still not a to-do list. Let's fix that. In JavaScript, the way you create a list of items is by using an array. We'll do the same thing here by updating the state in our to-do list component to be an array of to-do objects rather than just a single to-do object. Now, if you try to edit a to-do item, you'll notice that we get an error. That's because we need to update our handle update to do function to treat to-dos as an array rather than a single to-do object. Now, before we do that, let's take a moment to learn about how you can update array state in React. Admittedly, the knowledge you need for updating array state in React doesn't have anything to do with React. It's all just JavaScript. This is a good thing because it means the knowledge is portable to other JavaScript projects, not just React-specific ones. You can break the process of updating arrays down into 3 use cases: adding elements, removing elements, and updating elements. Here's the canonical way to do each. To add an element to an array, use JavaScript's spread operator to spread all of the existing elements onto a new array with the new element. To remove an element from an array, use JavaScript's filter method to create a new array, filtering out the element that should be removed. And to update an element, use JavaScript's map method to create a new array, updating the specific element where appropriate. The takeaway from all of these examples is we're never modifying the original state array, and we're using built-in JavaScript array methods to make our transformations. Regardless of what type of change you're making, these things should always hold true. Now with this knowledge, we can now update our handle update to do function to treat to-dos as an array. We'll use map to create a new array, updating the specific to-do item that was passed to handle update to do. Now, one thing to notice is that we didn't have to change the implementation of to do. All to do cares about is it receives a handle update to do prop that it can invoke, passing it the updated to do item. What happens when it's invoked is an implementation detail of to-do list and is irrelevant to to-do. At this point, things are progressing nicely. Before we worry about adding new to-dos, let's give the user the ability to delete them. Again, the rule of thumb is we want to update the state where it lives. In this case, because to-do list is the component that owns our to-do state, we'll want to create our function for deleting to-do items in the same component. Let's call it handle delete to-do and have it take in the ID of the to-do item to delete as its only argument. From there, we'll pass handle delete to-do down as a prop to our to-do component. And finally, we'll add our new handle delete to do prop to an event handler inside of to do, and then invoke that event handler whenever the user clicks on our new delete button. So at this point, we have the world's most useless to do app. Though peaceful, without the ability to add new to-dos, it's not very useful. Let's start with changes to our to-do list component. One more time for those in the back. Because to-do list is the component that owns our to-do state, we'll want to create our function for adding to-do items in the same component. Let's call it handle add to do and have it take in a new to-do item, which it'll add to our to-do state. Now we need to figure out where to invoke handle add to do. We could invoke it in our to-do list, but that would require us to add a new input field and state to our to-do list component. Instead, let's abstract that into another component. We'll call it to-do composer, and it'll receive our handle add to do function as a prop. Now inside of to-do composer, all we need to do is get the new to-do item from the user and then pass that to props.handleAddToDo. Now let's add some state and an input field to our component to keep track of the label of the new to-do item. Next, let's create a function that will handle actually creating our new to-do object. This function would usually live on a server somewhere so that we could generate unique IDs, but for our use case, we'll just fake it. And then from there, we'll create an event handler that will invoke our new handle add to do prop, passing it our newly created to-do item, and then clear the state of the input field. Finally, we need to hook our handle add to do click event handler up to a new button the user can click to add their new to-do item. And that's it. We now have a fully functioning to-do app. Though it may have been painstaking, hopefully at this point you feel confident with all aspects of managing state in React, including updating objects in array state, as well as lifting state up.